Hi everyone, welcome to my channel Python Tutorials. Here we'll explore tech, tutorials and so much more.
Hi everyone, welcome back. I am Prachi and I am an engineering student doing community service for my community development project. So I am teaching Python on YouTube and this is the lecture 3. I hope you have watched the first 2 lectures. If you haven't, go check them out. And till now you have learned how to set up your Python environment. Also you know about how to print the statements and what are variables and also the data types of Python. In today's lecture you will know how to take input from the user and then typecasting and about the arithmetic operations. So let's
Before we
get
get started for today's topic, let's quickly review the homework from last lesson. In last lesson, I gave you the homework to calculate the simple interest. So I will do it for you and you can see. First, we will assign the variables. Principal. Let's take principal as 5,000. And then rate as 5% and time let's take for 2 years. Now simply we will calculate it. Simple interest equals to, now the formula for simple interest is principal into rate into time divided by 100, right? So principal multiply by rate multiply by time and this divided by 100. So now we will print this and simple interest is comma and then the result we will write here simple interest. So you understand this? Now let's run the program. Yeah, you can see here the simple interest is coming as 500. So it's quite easy one. I hope you all understand what's happening here. I will show you once again. Principal, we have here assigned the variables first of all. Principal 5,000, rate 5 and time 2. And then we have simply calculated the simple interest by applying the formula. Look at here. Whenever if there are parentheses here, the Python always calculates the parentheses first and after that it calculates the next part. So it will calculate this principal into rate into time and then divided by 100 and then we have simply printed it. Yeah, so that was the yesterday's lecture and today I will teach you how you will take input from the user. Like we have taken principal ourselves here, right? 5,000 and rate also and time also. I will tell you how you can take this principal, rate and time from the user that is using your program or app, whatever you make in future. So these are the interactive programs which take direct user input from the keyboard. And I will teach you how to convert data types using typecasting and how to manipulate that data using mathematical operators. So let's get straight into the code. First of all, that comes is the input function. Let's make a new file for lecture 3. Lecture 3.py. Always remember to put the extension so it's easier to find out. It tells the computer that it's a Python file. So we have here section 1, that's taking user input from keyboard. make a program interactive, Python gives us a built-in function called input function. It's written like this: input. Like this. This is the input function. Now let's see how it works. I will type a variable name, our assignment operator, and then the input function. Okay. We will take here user name equals to input, then enter your name. And then we will print hello, then print that username. Okay, now let's run this code and watch what happens in the terminal. See here, you can see that print statements are not working yet, but the input statement is working. It's showing you enter your name. So if I write here my name, and then when I press enter, see, it's showing hello Pachi. The program didn't just run and instantly close here. It printed enter your name, and now a little cursor is blinking, waiting for us. The input function poses the entire Python interpreter. It freezes time until the person behind keyboard types something and hits the enter key. And when I type Prachi and press enter, boom, the program unfreezes, reads what I typed, stores it in the box labeled username, and then prints hello Prachi. This is incredible. We just made our first dynamic program. So now let's dive deep into it and make a better program. Now let's try building a simple calculator. Let's ask the user for two numbers, add them together and print the result. Watch closely because we are about to hit the biggest trap in beginner programming. We just name it as simple calculator. Okay. So variable 1 we will take as num1, and here input, enter first number, and then the second variable as num2, input, enter second number. Okay, and now we will take result and add these numbers, num1 plus num2, and then print the total is print result. Let's run this code. For first number, let's take 10, and for second number, let's take 20. In maths, 10 plus 20 equals to 30. So let's hit enter and see what Python says. Do you see this? It gives you 1020. It didn't add them up. It literally glued 20 right next to 10. Why did this happen? I showed you string concatenation yesterday. It's the case of that. Here, the golden rule of inputs in Python is that the input function always, without exception, returns your data as string. So this 10 and 20 here is returned as string. It does not matter if you have typed a number, a decimal or text. Python looks at your keyboard strokes and treats them like dead text characters. To Python, you didn't enter the numbers 10 and 20, you entered the text symbols. That is 10 and 20. The Python treated your 10 and 20 like this in the double quotes. And as we learned in the last lecture, we use plus sign between two text strings. It performs string concatenation. It stitches them together. So how do we fix it? To fix it, we use something called typecasting. The name is difficult, but it's easy. Typecasting. So yeah, first let's revise it again. So I have showed you how to use the input. We can take any kind of input you want from it, and we made a simple calculator here which takes num1 and num2 as the first and second number. But because it takes string, it only adds the strings. And then simply you can take any kind of input. Name equals to input, enter your name. For example, like you are making a game and you need the player's name, like here, player name and this, and then you print welcome and print the player's name. Print it and then you put your name here, and you can see it welcomes the player. So using the input statement is very easy. In other languages it's very difficult to use them actually, the scanf and all that things, but it's easy in Python. So let's go to the second section of our work. That's section 2. Typecast. That is converting data types. So yesterday I taught you about the data types in Python. I hope you remember those types. What were they? The first one was integer. The second was float. Third was string. And the fourth one was Boolean. So, like now you saw that when you take the input, it only takes the string. But if you want to make the calculator, we need to take the input as integers or float. So we have to convert that string to the integer or float. And there are simple Python functions to do it. First of all, what is typecasting? Typecasting is just a fancy word for forcing Python to change data from one type to another. Python gives us inbuilt functions that match the data names. I'll show you an example. Like first of all, int function, then there is float function, string function, string str function. So let's see how they work. I'll show you this. So see this one. See this int function here converts string or floats into the whole numbers. You can see here it's removing the double quotes and simply giving the 5. And float also converts values into decimals for precise maths. And string converts number back into the text format. Okay, let's try some examples now. We will take now age text. First two. Let's just take age. I have written 25 in double quotes here. Now we will print type. I told you about type function also in previous lectures. Now you know that this is a string, right? Let's do it again. If we take actual age and then use this int function here. Use int function and then put the first age in here. And then we print type actual age. Now we have applied the int function, so this becomes an integer. By wrapping the age inside the int function, we told Python take those characters, look at the numbers inside them and convert it into real mathematical integer and store it in a new box. I will show you by running it. Here you can see the first one is giving string, the age, and then second for actual age where you use the int function, it's giving the class int. So the typecasting is done here. So we have done this one, so let's fix our simple calculator. And with simple calculator, we'll take num1 and now here we will put the int function first and between it input function, because whenever I told you whenever there are parentheses, the Python processes the data inside the parentheses first. So input the same, enter first number, and for num2 int input, enter second number. And result equals to num1 plus num2. Now we will print the sum of numbers is print result. Now you see here we have taken in function before both are input statement. So the string in the input statement will be converted to the integer first and then calculated here in the result statement. So it will give us the same result. Let's run it. First number again we will take as 10, second number as 20, and now the result shouldn't be 10 20, it should be 30. See here, the sum of numbers is 30. Now it's treating the input as integers. By typecasting, the input immediately turns into integer. The plus sign now performs the actual addition. But wait, what if a user wants to calculate decimals? Let's try running this exact code and putting a decimal value here. If instead of 10 I put in 10.5, it gives an error. The terminal says value error, invalid literal for int with the base 10.5. Don't panic. Let's read what the computer is saying. It's saying, hey, you told me to convert this text into an integer, that is a whole number, but you gave me a decimal point. I don't know how to convert a decimal into a whole number without losing data, because it will lose 0.5 here, right? If a program needs to handle the decimal, you shouldn't use int function. You should typecast using the float function. Let's modify our code to make it bulletproof. Here, instead of int function, we will remove it and put in float function. Same for here, remove int function and put in the float function. Now all the inputted values of num1 and num2 will be converted into float. Let's run it again and see here. 10.5 with 12. Let's take it as 12. Even if we put it as 12, the Python compiler will change it into 12.0. So when we enter it, you can get the result 22.5. Right? So always think about what kind of data your user might type before choosing your typecasting function. It's very important to do that. We can also make a simple interest function here again. I will show you. Well, simple interest we will take in. We will take the principal as int float. Input, enter principal amount, okay. And then our rate as float again. Input, enter the rate, and then time equals to float, input, enter time. And then we will take same formula, simple interest equals to principal multiplied by rate multiplied by time divided by 100 is simple interest. Let's run it. So wait a minute. Let's take the principal amount as 5,000 only, and rate we will take as 5.5, and let's take time as 2.5 years. Okay, and see the result is 687.5. So it has taken everything as float here, and we can take any input from the keyboard only. Yeah. So this is also complete. Let's move forward to the next section, that's arithmetic operators. Section 3 is all about arithmetic operators. Alright. Now that we know how to harvest numbers safely from our users, let's explore all the mathematical tools Python gives us. Most of these are straightforward, but a few have secret quirks. So I will show you. We will take simple numbers as a equals to 15, b equals to 4. Okay. Now let's directly print it. First, let's go for addition. And subtraction. Okay. Let's print it. And simple a plus b. You can easily note what is the output. Output will be 19 here, 19 here, and here the output will be 11. It's simple, right? We will match the outputs later. And secondly, we can take multiplication. I already showed these already to you, but let's do it again with examples and details. Here we will print a multiplied by 2, and what will be the outcome? Output will be 60. Let's run it and see. You can see here we have got same as what we have calculated ourselves. 19 for addition, 11 for subtraction, and 60 for multiplication. Now let's take a look at the division. Okay. Python actually gives us two completely different types of division, and this is highly important for engineering logic. Here we have standard division first. Let's comment it out also, so you can understand the division clearly first. We'll simply go for 12 and divided by b. What do you think will be the output? Output will be calculated 3.75. Let's run it. 3.75. Standard deviation using a single forward slash always returns a float decimal, even if the numbers divide perfectly. For example, if here I take 3 instead of 4, it will give the complete answer 5, but it will show you 5.0. Okay, but what if you only want the whole number of the answer? So yeah, what if you want the whole number part of the answer and you want to completely throw away the decimal remainder? For that we use floor division. I'll show you. Floor division. Now we will print a double black slash b, and its output should be, wait, let me change it to 4 again, and its output will be 3, completely cutting off the 7.5, 0.75. Let's run it and see. Just a minute. I think I need to close the terminal and print it again. Here you can see 3.75 when we use the standard deviation, and for floor division you have 3 only. 15 divided by 4 gives us 3 only. It doesn't round off, it simply cuts off the decimal tail. Next up is one of the most useful operators in the programming, the modulo operator, represented by the percentage sign. This does not calculate a percentage. Always remember, it has percentage sign, but it doesn't calculate the percentage. It actually calculates the remainder, the leftover after the long division. Modulo operator. I told you briefly about it yesterday also in last lecture. A modulo B. What do you think should be the output here? The output should be just like 4 divided by 15. So the output will be 3. Not because we have removed the decimal part, because it is the remainder. 4 3s are 12 and 15 minus 12 is 3. Let me comment it out and I will give you another example of it so you understand better. We will take here 29. Let's take 29. So 28 comes in 4's table and the output should be 1 in that case. Let's run it. See, 1 comes here. So programmer use the modulo operator constantly to check if the number is odd or even. Think about it. If a number modulo 2 leaves a remainder of 0, it's perfectly even. Finally, next we have exponential. Next operator is exponent. Sixth one. Exponentiation, which means raising a number to a power. We use two asterisks here. So what it means? It means 2 raised to the power of 3. That is 2 into 2 into 2. And the output will be 8. Let's run it and see. Okay. The output is 8. Let's play around a little more. So we are done with our mathematical arithmetic operations too. Let's revise it again. First we had addition and subtraction, very simple, just using the plus sign and minus sign. We can get any answer. Second was multiplication. There simply we use asterisk and the multiplication is done. Then most important were these three. Standard division, that was a single division, and it gives the output in the floor format, decimal format. Even if it fully divides, it has 0.0 in the end. And then we have float division here, and it uses double backslash. Always remember, it uses double backslash. This uses single backslash, and modulo operator uses percentage sign. So this float division results with only the whole number. It doesn't round off like that, it just cut off the decimal part from the number, and then the modulo operator returns the remainder, simply the remainder it gives, and it's represented by the percentage sign as I have already showed you. And final and last is exponent 1. Here we use the symbol of double asterisk, right? That means 2 raised to power 3. We can change the numbers here. We can numbers take 8 and 1 the board. You can see here the output, right? And you know now about the input function and also how to typecast them, and then the arithmetic operators too. Till now you have covered print, also print, input, int. You also know about type, id, int, floor, and string operator. This is float. Learn about these functions. till now, and it's very easy to use all of these. So, for the final part of our lesson, let's take a capstone challenge and homework. So, let's now build a age calculator. Let's combine everything we learned today, user inputs, typecasting, and arithmetic operators, to build a working age calculator program live here. Okay? So for it, first of all, we will take birth year, and birth year of course we will take as integer. Birth year can't be in decimal. Input, enter the year you were born. Okay, and then we will set the current year equals to 2026. Sorry, 2026. And then calculated year age will be current year minus your birth year. Simple. Then print statement. You will turn or have already turned this old in 2026, and then print calculated age. Look at how beautiful that is. The program dynamically poses, reads your birth year, converts it to a number, subtracts it from the current year, and print out your age. Let me show you. Scroll this down. And here you were born in 2007. You will have turned or already have turned this old in 2026 19. And that's right, I have already turned 19. Alright, so most of our topics for today is covered. Let me show you a different way to write this print statement now. You can write it in same here, but if you write it here, calculated age, even though it's a variable and should display your current age, it will not display because it's in the double quotes. So if I type here 2007, it will calculate your age, but here it's giving calculated age. If you want that in the same line, here is what you can do. You have to come out of this double quotes, put a comma here while in the parenthesis, and then put the calculated age here. And now see, what year we were born in 2007, and you can see 19 is coming in the same age, same year. And you can also put it in between. Like here, we have already turned this. Instead of this, we will do, and we will go for calculated age, and then double quotes start again. years old. Now let's run it again. 2005 you will or have already turned 25 years old in 2026, right? Like this you can format writing it here also instead of in the next line or at the end. Now that we have completed this one, I will give you the homework for today. So look here, wait. Alright, so this is your homework for today, the kilometers to miles converter. Let's build a practical tool for travelers, okay? Your task is to write a program that converts the kilometers into the miles. Look at the instructions. The first one is ask the user to input a distance in kilometers. You can use float in here, so the user can enter the numbers with decimals. Then look up conversion factors. 1 kilometers is equal to 0.621371 miles. Store this factor in a variable. Then calculate the distance in the miles using the multiplication. That is miles equals to kilometers into conversion factor. Then print a clean friendly message showing the result. For example, the distance in miles is 3.41. There is a bonus challenge for you. Try using the round function here to round the final answer. So it displays 2 decimal places and it looks super clean. So this is your homework for the day. Try to do it. I will show you the output, show you the code in the next lecture. Thank you. That's it for today.